How did Renaissance mathematics solve problems geometrically? Have you ever wondered how numbers and shapes came together during the Renaissance to solve complex problems? This fascinating period in history saw a remarkable transformation in mathematics, particularly in how geometric problems were approached. During the Renaissance, mathematicians began to combine algebra with geometry, creating new ways to tackle problems that had puzzled scholars for centuries. They did not just rely on traditional ruler and compass methods. Instead, they translated algebraic equations into geometric forms, bridging the gap between numbers and shapes. One of the key figures in this movement was Gerolamo Cardano, who, along with Niccolò Tartaglia, worked on cubic and quartic equations. They used geometric constructions to representing solutions to these equations, which previously lacked clear geometric interpretations. This innovative approach allowed them to visualize and solve algebraic problems through geometric means, making complex concepts more accessible. Another significant advancement came from René Descartes and Pierre de Fermat, who introduced coordinate geometry. They developed a system that assigned numerical coordinates to points on a plane. This innovation allowed geometric curves to be represented as algebraic equations, transforming geometry into an algebraic study of shapes. This connection between numbers and shapes enriched the understanding of both fields. At the same time, mathematicians like Blaise Pascal and Gérard Desargues explored projective geometry. They focused on geometric properties that remained unchanged under projection, without relying on algebra. This synthetic approach emphasized constructions and proofs based on geometric intuition, extending the work of classical Greek geometry. The Renaissance also saw improvements in algebraic notation. Mathematicians began using letters to representing unknowns and constants, simplifying the manipulation of equations and their geometric interpretations. This blending of algebra and geometry laid the groundwork for future developments in calculus and analytic geometry. In practical terms, these geometric solutions found applications in art and architecture. The use of mathematical perspective allowed artists, such as Leonardo da Vinci, to create realistic spatial representations on flat surfaces. The understanding of proportions and curves also influenced engineering and design, showcasing the connection between numbers and their geometric meanings. Renaissance mathematics solved problems geometrically by using constructions to representing and solve algebraic equations, introducing coordinate geometry to link algebraic equations with curves, developing projective geometry to study properties of figures, advancing algebraic notation for easier transitions between algebra and geometry, and applying these ideas to art and architecture. This period marked a shift towards an integrated approach where numbers and geometry informed each other, enriching both fields.